So this is the NCEA Level 3 Probability Concepts Practice Exam for 2017, and this is the one done by NZAMT. We're going to do question 1 in this video, and it focuses on simulations, which is a really important concept in this achievement standard. It's one that takes a bit to get your head clear on, but once you're clear on it and you understand the purpose of a simulation, then it's a guaranteed question that you can get good credit in. In fact, it's usually excellence credit. But you just got to make sure that you're really clear on the purpose of a simulation first, and that you can write about it too. So we'll do this one together, and then it's worth talking it through with your teacher and maybe practicing some more. They're in most past exams and also practice exams. So, question 1, who wears the trousers? Kylie feels strongly that 3/4 of the girls in her school want to have a change in school uniform that allows them to wear trousers. In a pilot survey, that means a kind of a trial run of a survey. So in a pilot survey of students in her class, she finds that 13 out of 20 of the girls surveyed are in favour of being able to wear trousers. Kylie decides to carry out a simulation to test to see how likely it is that this result would occur if Kylie is correct in her beliefs. So her belief being that 3/4 are in favour. She randomly generates the numbers 1 to 4 inclusive. That means including 1 and 4. She does this 20 times and records the number of times she gets a success if it is a 1, 2 or 3. So if she gets a 1, 2 or 3, that represents a girl being in favour of the change to trousers. A 4 represents being against it. The results of 100 such trials are shown below. So why don't you pause this video and just have a think about this, read it again, and try and get your head clear on what this is saying. So if you're confused, think of it like this. Each of those simulations, she's randomly generating 1, 2, 3, or 4. So each of those numbers is equally likely to occur. To represent a 3 and 4 chance of someone being in favour of the change in uniform, she's going to call 1, 2, or 3 being in favour. So that represents if the number 1, 2, or 3 gets generated, then that means that it represents someone being in favour of the change. And a 4 represents them being against the change. So she's done this 100 times, and you can see the results below. So in each of those 100 times, she's generated 20 random numbers to represent asking 20 different girls their opinion on the change in uniform. The worst result was 10 being in favour of the change. That happened once. That's what the frequency means. The best result was all 20 out of 20 being in favour of the change. In other words, the numbers 1, 2 or 3 occurred in all of them. And that happened twice out of 100 times. What were the most common results? And why? Well, the most common two results were either 15 out of 20 or 16 out of 20 being in favour. They occurred the most times. Why do you think they occurred the most times? Why isn't that surprising? Well, it's because she's set the probability as being 3 and 4, 3/4. Okay, so 3/4 of 20 is what? Well, it's 15. So you would expect around 15 to be the most common number of successes out of 20, wouldn't you? So what are we trying to do here? What's the point in all this? Well, in this achievement standard, we always run simulations to see whether some experimental results, like the 13 out of 20, are consistent with a model, like the 3 out of 4. The key idea is we expect variation due to chance and other things as well, but we expect variation. And what we're trying to do is we're trying to say, okay, if this model is true, this theory, and the theory is that 3 out of 4 are in favour, that's the model or the theoretical estimate. So if that's true, then would it be believable to get 13 out of 20, only 13 out of 20 in her survey? Okay, so let's just start writing this down, because it says to discuss whether Kylie should change her view about the fraction of girls wanting to have a change in uniform. In other words, should she revise and say that maybe it's less than 3/4 based on her pilot survey? So let's start by stating the obvious. That's always a good place to start. So Kylie's model estimate of the proportion of girls in favour of the change to trousers is 3/4. So how many would she expect on average out of 20 to be in favour if this was true? Or how many? What's 3/4 of 20? So 15, isn't it? So based on this, Kylie would expect 15 out of every 20 girls to be in favour of the trousers. However, her experimental result was only 13. The question is whether 13 lies within the variation you would expect to get either side of 15 due to chance. In other words, how bad is 13 really? So what the simulation does is it builds up a picture of how much variation we would expect to get between different samples of 20 girls being asked if the true proportion in the school in favour of the change was 3/4. And we're going to write more about that in a later question. This question is just asking us to say whether Kylie should change her view. So to answer that question, we need to look and see where her observed result of 13 fits in that variation. So 13 happened 10 times, you can see it here, out of 100, so that's 10%. But what we're really interested in is how extreme or how bad is 13. So therefore, do we just want to look at 13 or do we want to look at 13 and lower? The answer is we want to look at results of 13 and lower, because we wanted to see how extreme that is. So how many times out of the 100 samples, 100 simulations I should say, did a result of 13 or lower occur? So adding them up, we've got 10 plus 2 plus 1 plus 1. So that's 14 times, isn't it? So 14% of the time that happened. So let's just write that down. So 14 of the 100 simulations resulted in 13 or less people being in favour of the change in uniform. And the simulation, remember, was based on there being on average 15. So it was based on a 3/4 chance. Now 14 out of 100, it's low, but it's not low enough to reject that theory of 3/4. It really needs to be in the bottom 10% before we would do that. That's kind of the rule that we can stick to in this course. If it's in the most unlikely 10%, then we can say that the model is probably not quite right for our situation. But if it's not in the most extreme 10%, like this one's not, then there's not enough evidence to actually reject that model. So what do we write? Well, we write, as these simulations were based on a three-quarters of the girls being in favour, our result of 13 out of 20 would be within the expected variation either side of this. In other words, it's just not rare enough to say that the true percentage is lower than 3/4. True fraction is lower than 3/4. So, as these simulations were based on 3/4 of the girls being in favour, our result, or I should say Kylie's survey result of 13 out of 20 being in favour, is within the expected variation due to chance. So no, this does not give enough evidence for Kylie to change her view. So the key idea here is that we expect variation, and even if the true proportion is 15 out of 20, getting 13 out of 20 in one particular sample is within the expected variation you get just due to chance. Okay, part 2. Erin believes that only 1/3 of the students want to have a change in school uniform that allows them to wear trousers. How would Erin change the simulation to generate similar results, and how would she decide whether this pilot survey result is supported by her simulation? So, what's the difference between Erin's model and Kylie's model? Well, Kylie's model was 3/4 were in favour, and so she generated numbers 1 to 4 and made 1, 2 and 3 represent them being in favour. Erin wants to set up a simulation to represent 1/3 or 1 and 3 being in favour. So how might Erin do that? I want you to pause the video and think about that. Write down what you reckon. Well, one way Erin could do it, one way Erin could simulate a situation where 1/3 of the girls are in favour, is to randomly generate the numbers 1, 2 or 3, where 1 represents a girl being in favour and 2 or 3 represents her being against. So again, the pilot survey is still talking about the same pilot survey that Kylie did, which was where she asked 20 people and found that 13 were in favour. So again, we need to generate 20 random numbers from 1 to 3 and count how many ones we get. The number of ones that we get out of our 20 numbers would represent what? It would represent how many girls were in favour. So Erin would then generate 20 numbers from 1, 2 or 3 and count how many ones she got. The number of ones would represent how many girls were in favour in a sample of 20. This process would then be repeated lots of times, say 100 times. Why? To build up a picture of the amount of variation we would expect to get between samples of 20 if the true proportion was 1/3. Okay, so what we'd be then wanting to see is where 13, finding of 13, fitted within that variation. So what's 1/3 of 20? Well, it's less than 13, isn't it? So if we do it on a calculator, 20 divided by 3, so we would expect 6 or 7, around about 7, right, to be in favour on average. So the question is, how often, out of 100, how many of those simulations result in 13 or more being in favour, or 13 or more ones out of 20? And we want to see whether that would be believable based on this model, based on Erin's model of 1/3 being in favour. So if less than 10 of those 100 result in 13 or more, then we would say that that Erin's model is too low, and that there's probably more than 1/3. So if this happens less than 10 times, i.e. less than 10%, then we would say that Erin's model of 1/3 is probably too low, because it wouldn't be believable to get 13, as many as 13, if the true proportion was as low as 1/3. So if this happens less than 10 times, we conclude that Erin's model estimate of 1 in 3 being in favour is too low. Okay, so just have a read over that and get really clear on it. The key thing is we're using a simulation to see whether an observed finding, which is the 13 out of 20 in the pilot survey, is consistent with a model. And in this case, Erin's model is 1/3. If the model was true and only 1/3 were in favour of the change, then would we expect to get 13 out of 20, as high as 13 out of 20, due to chance? Okay, so part 3, why is it useful for a student to carry out a simulation before doing a full survey, and what assumptions are being made? So why do a simulation and what assumptions are being made? Okay, I want you to have a think about this. So pause the video. Think about those 2 questions. Have a go at writing an answer. Hit play when you're ready. So this question is really hitting on the whole purpose of a simulation. So why do a simulation? So she's got a pilot survey. Does she need to go on and do a full survey, or has she already got enough evidence to answer her question? Remember, what's her question? Her question is 1 in 4, no, 3 in 4, a realistic estimate of the percentage in favour based on her finding of 13 out of 20 in her pilot survey being in favour. And in general, it's useful to carry out it's useful to carry out a simulation to test whether some observed or experimental results are consistent with a theoretical model for the probability of something happening. Specifically, a simulation is done many times, or repeated many times, to build up a picture of the variation we would get between different samples, and I should say the random variation we would get between different samples if the model was true. So if our observed finding falls within this expected variation, then we wouldn't have enough evidence to reject that model. This saves us time, because if our pilot survey result falls within the central part of the simulated distribution, in other words, within the middle, say 90% of the simulated results, then there would be no need to revise or to change our model, and so therefore there'd be no need to actually survey more girls in this case, because we could just go with our model. There wouldn't be enough evidence to reject our model. Or you could say our model estimate of, say, 3/4 in favour would be believable, and hence no need to collect more data by surveying more people. Assumptions. What assumptions are we making? Well, the key assumption here is that a simulation only simulates variation due to chance. So it only simulates random sampling variation, random sampling error. So if our sample is a random sample from the whole population of the girls at Kylie's school, then that's okay. But it says in a pilot survey of just the students in her class. Now that's not necessarily a representative sample. It's not a random sample, is it, of the girls at her school. So therefore there may be non-sampling errors involved. That means there may be biases or distortions due to other reasons. Like her class, her class is going to be all girls of the same age. So it depends whether she's just investigating girls her age or not. Also, it might be streamed, or it might be based on options they've taken. So it doesn't, and depending on which subject line it's in, those girls might have different opinions on the uniform than other girls in her school. So therefore, and the problem is that the simulation is not going to take into account those sort of distortions or biases. So this assumes that Kylie's pilot survey used a random sample from all of the girls she wished to investigate, or all girls whose opinions she was interested in. The simulation only takes into account random variation, random sampling variation. You could say simulation will only mimic random variation. And as the sample wasn't selected randomly, there could be other biases not taken into account by the simulation. Okay, that's the end of this video.